So, yesterday we were talking about finding limits of rational functions when you have zero denominator but not a zero numerator.
Right, yeah.
And the whole deal there was it's a vertical asymptote, so you can do a little work to figure out whether it goes up or down or one of each. What's up?
Sorry.
That's right.
What's up? So sorry.
It's okay. All right, so any questions on that stuff we did yesterday? All right. All right, so today we're going to talk about limits to infinity. Okay? So, here's the deal. If P of x over Q of x is a rational function, then to find the limit as x goes to plus or minus infinity, doesn't matter which one, of P of x over Q of x, you must look, or you must compare, let's say compare the orders of P of x and Q of x. Okay, so the order of a polynomial, maybe that's a new word, maybe not. The order of a polynomial is just the highest power of x that appears. That's what the order is. It's the highest power x appearing. Thanks. What are you asking me to?
For me? Oh, thanks, Christmas. Thank you.
A scholarship.
So, highest power of x appearing in a polynomial. And that's what the order is. So rational function is a polynomial over a polynomial. If you have the limit as x goes to positive infinity or negative infinity of that rational function, then you just have to compare the orders, highest power of x on the top and the highest power of x on the bottom. And there's three possibilities. They're either equal, or the top's bigger, or the bottom's bigger, right? Those are the only three possibilities when you compare two numbers, right? They're either equal, or one of them is bigger than the other. Okay, so there's three possibilities. So the first possibility that I'm going to talk about is if the bottom is bigger than the top. So if the order of Q of x is greater than the order of P of x. So for example, maybe you have something like the limit as x goes to positive infinity of x minus 2 over x squared plus 5. The bottom has a bigger power than the top, right? Or maybe it's limit as x goes to negative infinity of 5 minus 3x plus x squared over x cubed minus 2x plus 7. Oh, that's so, and same thing. The bottom is bigger than the top, right? All we care about is the exponent of the highest power term. Okay, so 2 and 3, 3 is bigger. Up here you have 1 and 2, 2 is bigger. Okay? So here's the deal. If the order of q of x is greater than the order of p of x, then the limit is 0. That's it. Every time. So this limit is 0. This limit is 0. And I know that just because the bottom has a higher power than the top. Now let's think about why this is true. There's a really analytical way of thinking about it, and then there's just an intuitive way of thinking about it. Let's think about it the intuitive way. If you think about it intuitively, you basically have a bottom of a fraction that's growing faster than the top, right? Like if you substitute in a really large number here, like 1,000,000 or something, you have 1,000,000 on top, that's a big number, but then you have 1,000,000 squared on the bottom, which is a much larger number. And the bigger number you substitute in, the bigger the difference is between those two numbers. Like if you substitute in a billion and 1,000,000,000 squared, 1,000,000,000 squared is way, way, way bigger than 1,000,000,000, okay? So you have a fraction in which the bottom is growing bigger, faster, and so that fraction is going towards 0. Like just think about any fraction where the bottom is getting bigger and bigger and bigger, and the top is either not getting bigger or is getting bigger at a slower rate. Overall, that series of numbers is going to head towards 0 eventually. Does that make sense? Now, a more analytical way that you can think about it is you can just, like if I take this example right here, x minus 2 over x squared plus 5, I can just think about, or I can just divide every single term by the highest power of x that appears on top to be x, right? Like I could multiply this whole thing by 1 over x, and I could multiply this whole thing by 1 over x. So if I do that, what happens? I get, if I distribute this, I get 1 minus 2 over x. And then on the bottom, I get x plus 5 over x. Now, if I'm taking x getting bigger and bigger and bigger and bigger, and that's what's happening, because I'm taking the limit as x goes to infinity, it should make sense to you that this is definitely going towards 0. That's going towards 0, right? Because you have a fraction where the bottom keeps getting bigger and bigger and bigger, but the top's staying 2, right? So that fraction is going to be like 2/10ths, 2/100ths, 2/1000ths, 2/10,000ths, 2/1,000,000ths, right? It's going to keep getting smaller, smaller, and smaller, and smaller, and smaller. Same thing goes for this. This term is also going towards 0. So if this part's going towards 0 and this part's going towards 0, then the whole fraction is really going towards 1 over x, which is going towards 0, because x is getting bigger and bigger and bigger and bigger. 1 over x is going towards 0 as well. Everything here is going towards 0. Does that make sense? So that's like a more analytical way to think about it. But I just think it's easier to just think of like orders of magnitude, like rate of growth. The bottom is growing faster than the top. So for big values of x, that fraction is going to head towards 0. Okay? The second possibility is if the order of q of x equals the order of p of x. If the orders are equal. Okay, so for example, you might have something like the limit as x goes to negative infinity of, hello? Okay, sure. Yep, bye. Jody, you have to go to dash. So limit as x goes to negative infinity, what if it was something like 5x squared minus 2x plus 1 over 4 minus x squared? The order of the top is 2, and the order of the bottom is also 2. So if we think of this in the same terms, in terms of rate of growth, the rate of growth of the top and the rate of growth of the bottom are the same, right? Even though there's extra terms here, it really doesn't matter, okay? For really large values of x, this top term is going to get dominated by 5x squared. And this bottom is going to get dominated by negative x squared. Yeah, there's a little plus 4 there, but that plus 4 is so tiny in comparison to negative a billion squared that the 4, you can just sort of ignore it. It kind of becomes really insignificant and gets dominated by the other term. Yep, see it. Okay? So if the rate of growth is the same, then think of it as, like, for really large values, the top's getting close to 5x squared. The bottom's getting close to negative x squared. They can reduce, and overall, the fraction's getting closer to negative 5. Okay? All you're going to do is you're just going to take the leading coefficients of the top and bottom and make a fraction out of it. That's it. So then, the limit is the fraction of leading coefficients. Okay, so in this case, it would be negative 5. I just took the coefficient of the highest power of x here and the coefficient of the highest power of x there, 5 over negative 1. And that's the answer. Okay? But again, just think of it in terms of rate of growth. Let's do another example like this. Like if I have something like the limit as x goes to positive infinity of 5x squared minus 2x cubed over 7x cubed plus 2x squared minus 5x plus 1. I'm observing the fact that the orders are the same. They're x cubed on the top and x cubed on the bottom. So the limit is just the fraction of leading coefficients. The leading coefficient on the top is negative 2. Now, leading is a misleading term, actually. It doesn't have to be the first coefficient. It just has to be the coefficient of the highest power. So you're going to take the coefficient of x cubed here and the coefficient of x cubed here. And that's it. So the answer here is going to be negative 2/7. Does that make sense? Because the top and bottom are growing at the same rate. Okay? And then the third scenario is if the top is bigger, if the order of p of x is greater than the order q of x. Okay, top has a bigger power. Like, for example, the limit as x goes to positive infinity of 5x squared minus 2x plus 8 divided by x minus 1. So let's just use intuition. The top is growing at a faster rate than the bottom. What do you think this answer is going to be? If you have a fraction in which the top is getting bigger and bigger and bigger faster than the bottom, what do you think that limit's going to be? What's that? Infinity. And remember, in delta math, that means the limit doesn't exist. So you just say, this does not exist because the top's growing faster than the bottom. Okay? So the answer is, then the limit is infinite, which means it does not exist.
That will always be the case.
Yeah. Yeah. So it doesn't matter how complicated the thing looks, it's really easy to identify. If you have the limit as x goes to negative infinity of 6x to the 20th power minus 2x to the 18th power over 51x to the 19th power plus 8. The answer is does not exist because the order of the top is 20 and the order of the bottom is 19. Okay? Now sometimes they might try and fool you by adding square roots and things like that. Like for example, suppose we had something like the limit as x goes to positive infinity of the square root of 16x to the fourth minus 2x squared plus 6 divided by 5x squared plus 1. Something like that. So what's the order of the top in this case? It's 2. Does everybody see that? Because the highest power is 4, but the whole thing is square rooted. So if you take the square root of a fourth root, you actually get a fourth power, you get a second power, right? Right. So remember, a radical is like a fractional exponent. So you really just divide this by 2. If it was a cube root, you divide it by 3, right? If it was a fourth root, you divide it by 4, and so on, right? So the orders are actually equal in this case, right? This is a highest power of 2. This is also a highest power of 2. So thinking back, if the orders are equal, then the answer is the fraction of leading coefficients. Yeah, the coefficient on the bottom is definitely 5, but the coefficient on top is not 16, it's the square root of 16, right? That square root kind of goes with that coefficient also. So this answer would be 4/5. Okay? Or what if they gave you something like this? What if they said, find the limit as x goes to negative infinity of the cube root of 5x to the 7th minus 8x to the 8th over x cubed minus 5x. What's the order of the top? It's not 2. No. 8/3. Right? Because the highest power that appears under the radical is 8, but the cube root is really a 1/3 power, right? So this is 8/3 when you sort of like don't think of it as distributive property, but when you think of the cube root of x to the 8th, it's really x to the 8/3 power, right? So the highest power of x on the top is 8/3. What's the highest power on the bottom? 3. Which is bigger, 8/3 or 3? 3 is. This is 9/3. 8/3, 9/3. So if the bottom is bigger, what's the limit? 0. This answer is 0. Simply because the bottom has a higher power than the top does. Even though that's an 8, it's really an 8/3 because this is cube root. Following me here? Now, if this happened to be x squared, then the answer would be does not exist because the top has a power of 8/3. So the top would be growing faster than the bottom is. Does everybody understand? So there's only really 3 possible answers. If the bottom is bigger, the answer is 0. If the top is bigger, the answer is does not exist. And if the orders are equal, then it's the fraction of leading coefficients. That's what you look at. So these problems are actually really quick. Looks like there's a lot, but it's not that much. And that's all there's to it. Okay? So stop recording. It's a delta math, and it's just called limits to infinity. Yeah.